If it doesn't work the normal way, you do negative. Yeah.
Okay. So as I said, you guys keep going here. So make sure when you get this that you read each what the instructions at the top. And then on each one of them, it's going to tell you if you're rounding it or if it's exact. Okay, so make sure that you follow the instructions based upon that. Okay. When you're done, you can just turn it in to me. Patiently wait until either 10 after or whatever it might be. And then we're going to be starting our last unit in here, which we will test on Thursday. Didn't show what?
This period.
They may have printed off the first period. They may have printed off the whole thing.
I need one. Because on my other periods, we set this one.
Just write it in. This is not. They just try to make it easier on you guys, so just put it in here.
Okay.
Bless you.
Hmm?
Please.
Sure, need to take it now. They're gonna be turning it in 5 minutes. We're gonna be starting the notes then, so. What would be best for you? Okay. I mean, you're saying just so. You're gonna miss, you might miss some of the beginning notes then, so go ahead. Okay. We're gonna get ready here in a second to start some notes. There we go. Oh. What in the world just happened? Undo that. Okay. Close this. Leave that. Good. You will want to have out Desmos today. Going through the lesson. Dun, 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 doodle-doodle-doo. What happened to? That's what I needed. Delete. I don't care about that. Delete. Don't care. Okay. Let's pull this up. Why does it look like that? There it is. You guys going here? Why is that not working? All right. So this is what we're going to be doing today. This is our last unit. And this is at the very end because this will be like where you somewhat start next year in either calculus class. No matter which one you're in, you're going to start kind of the exact same places. So you're going to have to understand what's going on today and tomorrow. And then Thursday, you're going to have a test on this. And it should be an easy test if you're with me, paying attention, following along, asking questions. In the past, this has always been a really good test to end the year on. So that's why I'm hoping that will be the same for you. Okay. So, I don't know why that just happened. Or that. I didn't do that. All right. So we're not even going to be dealing with trig at all. We are completely done with the whole concept of sine, cosine, tangent this year. We're not going to be talking about that right now. We are going to be going back and talking about polynomials. So I guess my first question for you is, when you see the word rational, what does that even mean? And I don't mean anything like English, like somebody's acting rational. In math class, what does the word rational mean? Like, what's a rational number? What does that mean? Yeah. Does have a definite value, which means that
It's either an integer or can be defined as a ratio up to integer.
yeah, it's any number that can be written as a fraction, basically. Okay, if you can write it as a fraction, it's a rational number. So number 5 is a rational number because it's 5 over 1. 2/3 is a rational number. Radical 3, though, is an irrational number. You can't write it as a fraction. Okay, so we're talking now about rational. So we're talking about fractions. Okay, so we're talking about fractional functions. Now that may sound scary to you, but don't freak out. Okay. So our main goal today is to talk about this idea of rational functions, what they are, and the parts of them. Okay, so let me first of all define what a rational function is. Okay, so a rational function is defined as, here's f of x equals p of x over q of x. A rational function is a function where P and Q, these two functions are polynomials. They are polynomials. That goes all the way back to Algebra 2, polynomials. Okay? And the bottom polynomial, Q of x, must have a degree that is greater than or equal to 1. And it, of course, Q of x could not be equal to 0. Why? Because we know by now that the fraction, in a fraction, the denominator can never be equal to 0. Now, let's just write down what polynomials are. Like, what polynomials are the sum or difference of monomials. Okay? And monomials are anything that can be written as x to the first power, second power, third power, fourth power, fifth power, so on, so on, so on. So like this, that's a polynomial. Okay? This is a polynomial. This is a polynomial. This is a polynomial. Okay? Those are all polynomials. Now, what did it mean by degree? Who remembers what that was? Like, what's the degree of this x plus 1? Yeah, it's a first degree polynomial. This is a second degree polynomial. This is a third degree polynomial. This is again a third degree polynomial. It's the what? The largest exponent for the variable x in this case. Okay? Now notice it says it has to be greater than or equal to 1. So all of these would be good examples of polynomials that could be the denominator. Notice it doesn't say the numerator has to have a degree greater than or equal to 1. We'll talk about that here in a second. All right? So the first thing is understanding, hey, do I even have a rational function in front of me? Now, what I did earlier is I wrote down, while you guys weren't over here, I wrote down some examples of
what are rational functions and what are not rational functions. So on the left-hand column here, you come back and keep going, guys. Okay. This is our subject.
Why is she putting that donut on? How is she? That's nasty. Yeah, that's gross. But you put. Oh, holy, it's not bad. You know what? Strengthen the immune.
It's my outcome when I came out. But then it would be wet.
Yeah, but then I dried it off my shirt. How do you know it's on my shirt?
So, we're watching it?
Riley, we're mulching Mr. Duncan. Just to get.
Any
I don't
kind
know,
of.
just to check. We're gonna try. You see? Yeah, that's your boyfriend. That's your boyfriend. I was gonna say. So, did you eat breakfast? I did breakfast. Sam, I have all your food. Who? Sharon. I did Sharon. Who's Sharon? Oh, how did she get that from? Man, that's right there. Yeah. Why? It says a big character or a few.
I'm still gonna read it because the exam's over.
Oh. Oh. There. Okay. It's ridiculous. Think about buying it in Coca-Cola. What?
Yeah.
Thursday.
Because we have to do for 16.
What?
Okay, so I think Thursday, my opinion, Thursday, you go to and they're gonna do break down.
What?
But then you choose which classes you're getting. So, Thursday. And then you turn it into,
I already know them.
Friday is like when you turn it into your 5th, 6th.
You know,
Friday
what do you
is
use to, what do you use to?
I'm only taking
Spanish, German, and chemistry.
I would do that to German.
This is not multiple choice.
I'm in
Spanish, bro.
No, just drop German.
Evan said you were gonna go in there, write his name on it, and turn it. Why would I think this is that hard?
I'm only taking one
They
exam.
literally have
I'm taking one exam.
Alright, you don't see anything.
What?
How are you opening taking one exam? Don't you have like
I taught classes, but I already took 2 exams early
why? How?
because they were both presentations. Project.
Oh, and so that your exam is what?
So for one class, I have to listen to people present, but everyone's gonna finish, so it's just not as watching movies.
Yeah, like on your exam day.
Yeah, watching. Yeah. Just watch. So I'm only gonna go in for the first day of the exam. So then I'll be done.
I'd have to take 4 exams.
Just take 4.
Yeah.
Then take. Technically, I'm taking. I have to do it. I
How
don't
many? What's your schedule? What's your
study hall, then
your first period of study? Second period?
second period, on this week.
Okay.
Third period, this.
7 days. Or you have 6 months?
So then after this class, I go to French.
Well, okay, so this is previous history, this class, French.
French, then chemistry, then English. Well, and then I'm doing it online too. Because I was supposed to do it in person
What was it?
online career readiness. It's the easiest class ever. And I'm doing a presentation. So I have like everything done before.
Shut up, baby. See, basically, like 3 days.
Yeah. I have to take 4 exams right that are due.
I literally have,
Because
I
my
have
French
3
teacher,
exam exemptions. I still have to take 4 exams.
my French teacher's letting me take her exam in my first period, so I can just be done with all my exams. Because I have a study.
What French are you?
One. Because I already took Spanish 1 and 2. So I'm doing this.
You're doing 4 and 4.
What
year?
Well, let's just focus.
Are you in
German?
No. But it just took me. What is he? German was a study. I literally do my Spanish homework.
Okay. So, you left off. So we left off right here, guys, talking about some examples of what rational functions look like, what they're not. So on the left, all of those are rational functions. Okay, on the right, those are not rational functions. So we notice that on the left, like on the left one, the top has a degree of 2, the bottom has a degree of 1. The second one has a degree of 5 in the top, a degree of 3 in the bottom. The bottom one, what's the degree of the top? H of x. What's the degree of the top polynomial? Because that is a polynomial on top. It's a 0. Why? Because it's x to the 0 plus 3. It's a constant term, okay? The bottom is linear. That's a first degree polynomial. So the top number, the top polynomial could be just a constant term, but you'll never have a constant term just on the bottom. Notice over here, I said this is not a polynomial. I mean, not a rational function. Now, this is obvious not because it has a square root in it. That's x to the 1/2 power. That's not a polynomial. This is not because that's exponential. That's not a polynomial. But this is a polynomial, and that is a polynomial. But it's not a rational function because this has a degree of 0. And I could rewrite this as this. And when I do that, it's just a plain old polynomial. So that's why the bottom has to have an x to some power other than 0 in order for it to be a rational function, right? Now, we have two primary goals today. Two primary goals today, all right? Those primary goals are the following. 1, find all asymptotes. We're going to talk about those in a second. For a rational function. Okay, that's the first thing we're going to do today. Find all asymptotes for a rational function. The second thing we're going to do today is we're going to be able to find any holes in a rational function. We'll talk about that as well. Tomorrow when you come in, we will have one third goal, and that will be to find limits for rational functions. That will be tomorrow. Okay? So our two goals today are finding all asymptotes for a rational function and finding any holes in a rational function. Right? Again, tomorrow will be the last day. We'll make sure we're okay with this, and then we'll find limits for rational functions. Okay, so here we go. So what I'm going to do is I'm actually going to take these and I'm going to graph one Desmos, and then we're going to talk about it real quick. So here's my very first one. This is kind of like the parent function. This is the most basic rational function that exists. F of x equals 1 over x. So I'm going to go ahead and call this up. I'm going to just graph this real quick. So I'm going to actually bring it over here. So f of x equals 1 divided by x. And I don't know why it's capitalizing still. Let's do this again. F of x. And let's make this a regular x in the denominator. Okay, there it is. Boom. There's the graph. Looks different than anything we've seen in the past. Okay, so let's talk about this first of all. Will this function have any x-intercepts? I see some people shaking their head. No, it will not. Why will this function not have any x-intercepts? Why is that true, though? Yeah. Right. There's no possible way on this function, guys, to make the fraction equal to 0. Because a fraction can only equal 0 if the numerator equals 0. So this is never, ever, ever going to equal 0 if you have a constant term on the top. It's impossible. Okay? So that's the first thing I notice. Will this, listen very carefully, okay? Will this have any y-intercepts? No. Why not? So far we've said no x-intercepts. And I asked about y-intercepts. What's the value of x for a y-intercept? If I let x equal 0, what happens? It's undefined. If x equals 0, it's undefined. Therefore, there's no y-intercept either. Okay, so that's telling me a couple different things. So let's talk about this. There are two types of special lines we need to understand, and they're not really lines like you graph per se, they're boundaries, and they're referred to as asymptotes, okay? And there are two types of asymptotes. There are horizontal asymptotes and there are vertical. There's actually multiple. There's also oblique asymptotes or slant asymptotes. Our job, though, is we're going to talk about two in particular. Those are, again, horizontal and vertical asymptotes. Okay? I'm going to start with the horizontal asymptote. A horizontal asymptote, I'm going to write down this right here. HA, horizontal asymptote, is a horizontal, it's like a horizontal line that a graph approaches as x goes to either positive infinity. Remember that notation right there? We did this on end behavior a long time ago. As x goes towards positive infinity or as x goes towards negative infinity. So when I look at this graph, okay, if I look at this graph, I'm going to go ahead and use this right here. That's the wrong color. Let's go ahead and use this. No, I won't do that. Get out of there. Okay. So right here, at y equals 0, this graph, as I go to the left, as x goes towards negative infinity, this graph here is getting closer and closer and closer to the value of 0. And as this graph goes further and further and further to the right, the graph gets closer and closer to 0. This right here is referred to as a horizontal asymptote. Okay? It's not part of the graph, but it is important in understanding the graph. Now we have horizontal asymptotes. There's also vertical asymptotes. Okay? A vertical asymptote is a vertical line a graph approaches as, here we go, x approaches some x value to make function undefined. In other words, it's a value of x you're not allowed to use in the function because it makes it undefined. That's the idea. So what's making this undefined? X equals 0. That is this vertical line right here. There's x equals 0. Notice how the graph, as I go towards it, approaches it, but it's never, ever, ever going to hit it. As that gets closer and closer from the left-hand side, it's just going to keep going down, 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 and get closer and closer. It's never going to cross it. And then on this side, if I'm going this direction, as I'm approaching it from the right-hand side, it's going up, but it's getting closer and closer and closer to it as well. But it will never be able to be equal to 0 because x cannot equal 0 here. We know that. Now, what do we call the values of x in a function? The domain. So it kind of sounds like the domain has it kind of plays into the whole idea of the vertical asymptote. In other words, actually the domain of this function is, guess what? Negative infinity to 0 and 0 to positive infinity. I'm going to write it down here. The domain of this thing, let's think about that. The domain of this is negative infinity to 0 and 0 to infinity. Remember, the parentheses means what? The value is not included. This right here, guess what this value is right here? That's where the, what's happening? That's where the vertical asymptote is. That's the restriction on the domain in this problem. So we've got this thing called a vertical asymptote. Here's a horizontal asymptote. Now, I'm actually going to give you a very, very, very easy way of finding these in a second. So just relax. We're going to do another one here. Okay. What do you think? Now, I just want everyone to think. Before I graph it, where do you think the vertical asymptote is going to be for this? Where's the restriction on the domain? When's this going to be undefined? When x equals what? 0. So it's going to have a vertical asymptote at x equals 0. And then the horizontal asymptote, okay? Think about it. We said this is never going to be equal to what? A fraction that has a constant in the numerator can never equal what? 0. So it's going to have a horizontal asymptote at y equals 0. I guarantee it does. Let's try it. I'm going to graph it and look at it. Okay? I'm going to graph it and look at it. So here we go. Let's call up our function. So we're just going to change this 1 to a 4. And boom, you'll notice, hey, if I zoom out, you will now see it. And there it is. It's got the exact same horizontal and vertical asymptotes. No different. So that constant term has no bearing. That constant in the numerator does not change the horizontal or vertical asymptote. It just stays the exact same. Okay? Boom. I love it. That's great. Okay. And you're supposed to paste. There it is. Great. All right. So this has the exact same. So if I wanted to draw those, I could go ahead and draw my asymptotes on here. I could draw a horizontal at y equals 0. Here's the horizontal asymptote. I always draw a dotted line to show asymptotes. And here's the vertical asymptote at x equals 0. And you can see that those two things, those two lines are kind of containing the graph. Okay. All right. Okay, let's try something else. Let's get a little different here. Now look, we know what this is going to look like. What's this going to look like now, I wonder all of a sudden? I've changed it a little bit. And actually, I don't even care about this too. I'm going to get rid of that. I want to just look at this one right here. What is this going to look like? Well, the first thing is we're going to go ahead and graph these together on one graph. You can just pay attention more than anything. You're just along for the ride. So I've got 1 over x. And then here we're going to put g of x equals 1 over x minus 1. Okay. So we already knew this one's going to have asymptotes at x equals 0 and y equals 0. Boom. What about this one? What do we notice? It shifted which direction? 1 to the right. Remember how we said before? If you add or subtract to the x value, it's a horizontal shift. Now think about why that happened. Why is it shifting 1 to the right? Because now if I put in the number 1, the denominator becomes what? 0, which is undefined. So that means that 1 is not part of the domain. So that's why on this particular problem right here, this guy is going to have a domain of negative infinity to 1 and 1 to infinity. That immediately tells me that 1 is the what? The what asymptote? Which type? It's the one that goes up and down, right? Because these are x values. So my vertical asymptote for this one was at x equals 1. Since there's a constant in the numerator, again, we know the fraction can never equal what? 0. That's why there's going to be a horizontal asymptote at what? Y equals 0. And if I go back to that graph, you're going to see that's exactly where they're at. You're going to have a horizontal at y equals 0 and a vertical at x equals 1. So let me go ahead, call that graph back up. And we can see that's exactly what's going on. If I even graph right here, let me graph it. X equals 1. Boom. You'll see right there. There it is. It's vertical asymptote. If I graph y equals 0, boom, you can see there's the horizontal asymptote on it. Right? So now we're going to go ahead. So we're starting to see that these rational functions have these asymptotes that show up in them. We're going to go ahead, cut that guy out, and put him on there as well.
let's go over here and we'll paste that one. Okay. Love it. Now, sometimes we kind of like to know how to do this without having to graph it. So notice what I have here now. F of x equals 1 over x minus h plus k. And what I really could put here, if I wanted to make this a little bit better, I believe, I probably should have typed this instead. Let me go ahead and I want to change this to the letter C. And what does C stand for? A constant. So any number could be on top. It doesn't matter what it is. 1, 2, 3, 4, 5, -8, -2, doesn't matter what it is. If you have a constant term over x minus h, and then if you had a plus k out here, that has an effect on the range. I don't really care so much about that one right now. I'm just going to cross this off. I want you to think about this one. Okay? This is going to have a what? Vertical asymptote at what? Now think about the one I just did here, guys. This was at, this was, what did I do here? X minus 1 cannot equal what? 0, right? That's the whole idea. So x cannot equal what? 1. That's the vertical asymptote then. It's what makes the denominator equal to 0. So here I'd have to say what? Well, x minus h cannot equal 0. So in other words, if x equals h, that's my what? Vertical asymptote. There it is. The vertical asymptote is at x equals h. Okay. Now, what would the horizontal be on this? Forget the k. What would the horizontal be on this one? Y equals 0. If it's a constant on top, it's y equals 0. What's the domain of this going to be? Negative infinity to what? H, and then h to positive infinity. Boom, got it. So this one over here we already did. So what if I wrote down the following? 5 over x minus 3. Vertical asymptote's where? X equals 3. Horizontal asymptote's at? Y equals 0. What's the domain? Negative infinity to 3 and 3 to. All we're doing is looking at these first ones where everything has a constant in the numerator, and in the denominator right now we've had a what? Linear, right? A first degree polynomial. Okay? All right. Anyone have a quick question? Let's see what my next problem is here. Cool. So here's what I got. I have all of these problems right here. Let's see if it'll let me go split screen on this or not. It's like it doesn't do split screen anymore like it used to. Dual page display. Oh, wait. On. Won't let me. Of course you won't. You stupid. Good. Great. All right, here we go. So here are a bunch of rational functions. Now notice they're different than what we've just had, aren't they? They're different. Because all of these now in the numerator don't have a constant term. They have a what? A linear function. All of these are actually what? Linear functions over linear functions. Are they not? You know what? Before I do that, real quick, I want to ask you, let's just try something here. What if I gave you this? What if I gave you this? We didn't do one like this. We should have. Now, I know you can tell me on this, guys. You can tell me right away where the horizontal asymptote is. Yes, the horizontal asymptote is y equals 0. Okay, great. Now, here we go. Let's talk about the vertical asymptotes. We said the vertical asymptotes are the values that make the denominator equal to 0. So I need to say, x squared minus 4 equals 0. That happens when x squared is equal to 4. That would mean that x is equal to positive and negative 2. Whoa, what does that mean? This has 2 vertical asymptotes on it. It's going to have one at x equals 2 and one at x equals negative 2. Let's check it out. Let's see what's going on here with this one. So we'll come over here. Get rid of that. Here we go. So we've got 5 over x squared minus 4. Turn it on. Boom. Where did we say they were? X equals negative 2 and x equals 2. Notice them. There they are. You can see them. Here's one of them. Here's one of them. So you don't always have one. You could have 2. You could have 3 maybe. Who knows? But here we go. Here are 2 of them. Okay? So I like that. That's a great extension of what we just did. Let me go ahead real quick. Boop, boop, boop. So again, the denominator, when the denominator equals 0, what do you have? The values of x that make the denominator equal 0 are the what of the rational function? The vertical asymptotes. Thank you very much. Thank you very much. Okay. Now, I'm going to stay here because I have these problems here. So I already have these other ones graphed. Now, earlier when I graphed them, I actually used my graphing calculator because Desmos was being wonky this morning when I was doing it. So I'm going to go through here and we're going to look at these problems. So I have all of these graphed already. So here we go. So here's the first one. Here is x minus 2 over x plus 3. Now I want everyone to look at it and I want you to tell me what you think the vertical asymptote is. You shouldn't have to think about it. Where's the vertical asymptote at? Negative 3. Yep, it's right here. 1, 2, 3. Boom. There's x equals negative 3. Okay, great. Where should this one be at? Positive 4. Let's see if it is or not. Oh, here we go. Positive 4. 1, 2, 3, 4. Yep, there it is. Okay, where would this next one be at, you think? Negative 2. Let's see if it is or not. Oh, yep, there's negative 2. I see it. Here it is, negative 2. This one? Negative 1. Yep, there it is. And then what about this guy? Well, I think it's down here. Where would this one be at? I'll move this up. Where would that one be at? Negative 1/2. Yep, negative 1/2. That's right here. Here's negative 1/2. Do we understand the vertical asymptotes? Okay, now let's talk about the horizontal on these. These are different because what? The numerator is no longer a constant. It's an actual polynomial with a degree of 1 or more. Let's go up here now and look at some of these. Where does it look like your horizontal asymptote is here, maybe? If you say 2, it looks like if I took 2 and came across, it would probably hit it. Looks like it's probably where? At x equal or y equals 1 maybe. Looks like it's right here, maybe at y equals 1. What about the next one? What does it look like? 3 is right here, guys. Looks like it looks like it's, I think this is the whole number again. I'll just tell you that. It's 2. Yep, and we're going to talk about it in a second. Right here. Y equals 2. Okay, great. This one. Yeah, it looks like it's right here at 1, 2, 3, 4. It looks like it's right here at y equals negative 4. This one.
3. Oh my goodness, I'm thinking that there must be some kind of pattern of how we're getting these so quick now. This bottom one. Careful. I tricked you on this one on purpose. If 4 is 1, 2, 4 would be 1, 2, 3, 4 is way up here. That's not going to work. It's at 2. And you're going, wait a second. The pattern just stopped. No, the pattern didn't stop. You didn't see the whole pattern. Here's where these are at. Everyone watch. 1 over 1 is what? That's that asymptote. 2 over 1 is what? 2. That's that asymptote. Negative 4 over 1 is negative 4. 3 over 1 is 3. 4 over 2 is 2. What do we call that number in the front of a polynomial? The leading coefficient. That means that leading coefficient is dictating something about the what? Horizontal asymptote. Okay? All right. So let's do this one real fast. Here's the graph. If I didn't even have the graph, my horizontal asymptote I should be able to find by doing what? How do I find the horizontal one for this one? It's the leading coefficient over the leading coefficient. So all I have to do is put this over this and write it as what? Y equals 2. 1, 2. There it is. Okay, the vertical asymptote. How do I find the vertical asymptote? Set the bottom equal to 0 and find the value. So it's the 0 of the denominator. What is the 0 of the denominator? Negative 1/3. That means what? X equals negative 1/3 is the vertical asymptote. That would be right about here. Okay, x-intercepts. Wait, this actually has x-intercepts because it doesn't have an asymptote at x or y equals 0. How would I find the x-intercepts of this? What part of the fraction dictates x-intercepts? The what? The numerator. Because when is a fraction equal 0? When the numerator equals 0. So the x-intercepts, that's when the numerator is equal to 0. Oh, 6x minus 8 equals 0. 6x equals 8. X equals 8 over 6, which is what if I simplify it? 4/3. So 1 and 1 1/3. Okay, great. That's right here. Boop. See it? There it is. So this actually has an x-intercept. Okay, I'm cool with that. How are we feeling so far? Pretty good? Or do you feel like you just walked into a foreign language? I don't know. We'll see. Here we go. All right. I haven't graphed it yet. This is different than the other ones. How? How so? Because now it's not linear over linear. It's what? Quadratic over linear. Before I ever put these down, let's look at the graph of this. I'm going to graph it and put it on the board, and then let's talk about what's going on. Now, right away, you should know where the vertical asymptote is on this. I should not even have to talk about that with you. Okay? So let's get rid of this. Okay, so it's 2x squared minus 8. And then I want this divided by, actually, let's do it this way. Get that out of there. Why did that happen? Come on, get out of there. Divided by 5x plus 1. All right. Woo, that looks different. Check that one out. That's crazy looking, isn't it? Does it have a vertical asymptote, though? Yes, it does. Where should the vertical asymptote be at? Tell me.
X equals negative 1/5. Boom, you can see it. There it is, right there. Does it look like it has a horizontal asymptote? Look at it. Is there a horizontal line this is approaching? No, there's no horizontal line this is approaching, is there? I mean, look at it. It's not. Because if it's approaching a horizontal line, my graph's going to do what? As it goes out to the right or left, it's basically going to flatten out. Is that flattening out as I go to the right and left? No, not at all. This one doesn't have a horizontal asymptote, it looks like. Okay, so let's talk about this one. The vertical asymptote we found. We said the vertical asymptote was at x equals negative 1/5. This one, the x-intercept, we should be able to find again. What's the x-intercept? When this is equal to 0. So I would say 2x squared minus 8 equals 0. That means x squared equals 4, which means x would be equal to positive and negative 2. And if you look on the graph, it crosses at negative 2 and positive 2. And then this one, we said it has none. Now, why? How is this different than the last one? They're not the same degrees, are they? This top one is bigger than the bottom one. If I made this a square, guess what? It would have a horizontal asymptote. So guess what? I want everyone to listen to me right now. This is important. If you're given a function, f of x equals a of x plus b over c of x plus b. Now, this is a linear over a linear, right? The horizontal asymptote, the horizontal is always going to be y equals a over c, whatever that is. It's the leading coefficients. The vertical asymptote would always be what? Yeah, you take cx plus d and set it equal to 0 and solve for x. That would be x equals negative d over c, if I solved it, in this case. All right? That's if it's a linear over a linear, right? They're both first degree polynomials. Okay? So this one, real quick. Where is the vertical asymptote and where is the horizontal asymptote for this problem right here? Where's the vertical going to be at? X equals what? Negative what? Not 3/2. Yeah, you move that over and divide by this. Negative 2/3. Where's the horizontal at? 5/3. If you graph it, you'll find out that's right. So if you have a polynomial, if you have a rational function with a linear over a linear, this is always going to be true. Okay, it's nice. Let's skip that. Tell you what, we already did one like that. I'm going to give you guys a little hint. I'm just kind of skip ahead here a little bit because of time. Look what this says. P of x, if this is my rational function, look what I have here. A polynomial over a polynomial. Okay? What's the degree of the top one? M. What's the degree of the bottom? N. Now watch. If M and N are equal, the degrees are equal, then you will always, I don't care if it's linear or not, it could be linear, quadratic, cubic. If the degrees are the same, you will have a horizontal asymptote at y equals a sub m over b sub m. In other words, the leading coefficients give you the horizontal asymptote if and only if the degrees are the same. Okay? That's what this is. This is nothing more than leading coefficient over leading coefficient. Now look what this one says. If m is less than m, in other words, if the degree of the top is smaller than the bottom. In other words, like a first degree over a second degree or a second degree over a third degree. If you have a scenario like that, it will have a horizontal asymptote at y equals 0. Boom, guaranteed.
at y equals 0. Remember the constant terms we did in here? That was those. Those are x to the 0 over x to the first power. That's why they all did that. Then this one here. If m is greater than n, if it's got a bigger degree up here than here, it will not have a horizontal asymptote. That's how you find the horizontal asymptote. The vertical ones are always what? When the denominator equals 0. The horizontal, okay, is determined by the degree of the top and the bottom. If they're the same, it's leading coefficient over leading coefficient. If it's got a bigger degree on the bottom than the top, it's y equals 0. If it's top heavy, bigger on the top, there is no horizontal asymptote. You need to memorize that. You need to memorize how do you find the horizontal asymptotes and how do you find the vertical asymptotes for a rational function. That really and truly is just 3 things to memorize. These 3 things, well, it's actually 4, I guess. These, and then how do you find the vertical? Set the denominator equal to 0 and solve. All right? So real quick, let's talk about this one. Would this have a horizontal asymptote? Yes, why? Because the degrees are if the degrees are the same, all I have to do is use the leading coefficient rule. What's that mean then? Y equals 2. Vertical asymptote. Set the denominator equal to 0. Talk to me, Deuce. Hold it. Can you have x squared equal a negative number and get a real solution back? No. Guess what? This does not have a vertical asymptote because it does not have any real numbers to make the denominator equal 0. Look at the graph. Here it is. I already have it. Graph. There it is. This is the graph of this function. There is no vertical asymptote. So none. Zeros, does it have zeros? I can see it has 2 zeros. What are they? How do I find the zeros again? Yeah, how do you find them? Set what? Set top equal to 0. 2x squared minus 8 equals 0. X squared equals 4. X equals positive negative 2. And you can see it here, and you can see it there. Okay, this is all about polynomials again, and it's about finding zeros and such. Now, everyone's going to just tell me this one real quick. We'll skip the zeros right now. Horizontal asymptote, yes or no? None. Why? Because it's top heavy. Vertical asymptote. X equals negative 2. Okay, if I want the zeros, set this equal to 0 and solve. Real quick, this one. Horizontal, no. Vertical, x equals negative 4. Again, 0 set equal. Guys, I'm going to post an assignment online. Find it. Find it and try it tonight.
No, you can.